The impulse goes through the sensory neuron first, and then to the interneuron, which passes message from sensory neuron to motor neuron, and then triggers the reactor. The sensory and motor neuron are made up of myelin sheath. Here we have the myelin sheath, which consists of layers of strand cells surrounding the axon. Between each myelin sheath is the knot of Ranvier. The action potential only occurs at the knot of Ranvier. The action potential jumps from knot to knot, speeding up the impulse. Here we show the resting potential. Sodium leaks into the axon and potassium leaks out the axon.
When the axon is not conducting an impulse, it is called the resting potential. The potential difference across the axonal membrane is about -65. This means the axon is more negatively charged than the outside. This is due to the negatively charged molecules in the axon, such as amino acid. During resting potential, sodium and potassium can leak out or leak in through sodium gates and potassium gates. The sodium-potassium pump is always working because the membrane is permeable to these ions. The pump helps to maintain the unequal distribution of sodium and potassium. Action potential has 3 stages: depolarization, repolarization, and the refractory period. When the nerve impulse goes through the axon, depolarization occurs first. Sodium gates open and sodium atoms rush into the axon by diffusion, making the axon positively charged at 40 millivolts. Repolarization occurs after. Potassium atoms rush out the axon by diffusion, and the axon is back at -65 millivolts. Now we have potassium outside the axon and sodium inside the axon. Another impulse cannot be conducted. This is when we have the refractory period. During this period, the sodium-potassium pump pumps sodium outside and potassium inside to change the axon back to normal. This is then ready to conduct another impulse.
This is the axon terminal. The axon terminal is the end of an axon. It contains synaptic vesicles enclosed with neurotransmitters. The area separating the presynaptic membrane and the postsynaptic membrane is called the synaptic cleft. When the action potential arrives at the axon terminal, calcium rushes into the axon terminal through calcium gates. The calcium atoms force synaptic vesicles to fuse with the presynaptic membrane. This part shows releasing of neurotransmitters into the synaptic cleft. After they are released, they bind to receptors on the postsynaptic membrane, permitting sodium to diffuse into the postsynaptic membrane, and an action potential begins.
Drugs can affect the nervous system by causing the neurotransmitter to leak out of a synaptic vesicle into the axon terminal.